This video is mostly just about me going and messing around with this Intex saltwater generator. I've had this for a couple years. Sadly, it's out of warranty. It started having the dreaded Code 91 problem, which is, according to the manual, an indication that there's low salt in the water. I test my water with salt strips, and I know for a fact that my water is not low. It doesn't have low salt. It's about 2,800 to 2,900, so something else is wrong. According to the manual, of course, if you read it in the troubleshooting section at the back, they say if there's low salt, well, then there's a chance you have corrosion on the titanium electrolytic cell. So before I go any further, this is the unit, of course. Here's the LED piece, the transformers in here. Flip it around the back. They refer to this entire piece as the electrolytic cell. This is where the flow sensor is. To give you an idea of all these different pieces, the water enters through here, and then the other pipe's on the end, and then goes through this. As it passes through, this little thing detects whether or not there's water flowing, and thus if water's flowing, it'll run, otherwise it'll cut off as a safety measure. This piece, this is the plug which goes to the sensor, goes inside, which I'll open this in a second to see it, but this plug has two prongs. There's these three plates, which we'll talk about in a second, that it detects whether or not the salt is low. And that's usually where all the problems seem to lie, is this whole piece setup. This last thing is, this is the copper electrode. It is what actually, when you pass a current through it, is what uses the salt in the water to produce chlorine, and thus eliminating the need to go and buy chlorine tablets and all that stuff. So, with that in mind, and by the way, that's something that I noticed some other people seem to forget. It comes with caps. Don't lose the caps. Don't throw them away. The caps are actually kind of useful because the next thing I'm going to talk about, the maintenance procedure, it's handy to have the caps. So you put the caps on it, and speaking of the maintenance procedure, what they say in the manual is you use some form of acid. They recommend standard household vinegar. You fill the entire cell up after you've disconnected it and prevented all the water, putting the caps, closing the valves, also set it on your pool. You drain it, put the caps on it. There's another video out there on the internet where someone shows you exactly what they do. And you fill the cell up, put this back on, and you let it sit there for an hour or more. That's assuming you have calcium stuff, you build up and whatnot. Of course, I tried that, and I didn't really have any scaling problems anyway. And nevertheless, I went through the process anyway, and I still get the Code 91. So there's some other issue. Done a lot of reading on the internet. A lot of people had a lot of ideas. And one of them I noticed, he mentioned that he tested the electrolytic, the cell itself, the titanium plates, with multimeter, and it occurred to me, based on what I remembered from college and digital electronics, that yes, I should be able to go and test whether or not my plates are functioning or not. So let's talk about that. There are, in here, and it's hard to see it, but there are three plates that have, what I've read, a titanium coating. They're connected up through here, and they have these two plugs, and of course that plugs into this, which actually goes into the computer board, which I'm going to take this off so you can see what that looks like. And if there's enough salt in the water, it'll support, it'll actually pass a bigger current. The resistance will lower, if you're thinking about Ohm's law, and thus the unit will sense that, hey, there's enough salt, so it won't cut off. But if there's a problem with this, you know, like with the scaling that they mentioned from calcium scaling or whatnot, then the sensor can't sense that there's enough salt in the water, so it will cut off. Or there could be some other problem. One person mentioned that there was rust somewhere in here. I actually do have some rust on mine. It's kind of hard to see, but it's in here. And yet the connection still seems to be solid, but we can verify that. In fact, I'll actually show you how to do that. One, of course, warning before I go any further. If you don't want to bother doing this stuff, and also, of course, this thing is an electrical piece of equipment, or piece of electrical equipment, so don't do this if you don't want to run the potentially risk of getting hurt. Don't do this if you want to potentially break your unit. Don't do this if you want to mess with your warranty or anything else, or if you just don't really care to take the time, don't do it. Watch the film, just see what it's like. I did this because I like to mess with things. And I was also wondering whether or not I actually could fix my unit before I bought another. So we have these two plugs, and I have my multimeter, and turn it on. We can check the resistance. We have open air resistance, which means it's going to be really, really high. What that means is with open air resistance, well, there's resistance. If I put these two together, of course, resistance goes down to almost nothing, as it should. In this case, if we check this out, we put our two leads on the prongs of the plug, it should drop. Now it's going to drift around a bit because that's the way it is, but hey, it's pretty high. And that's usually what you would expect with something that has no contact. Now, to get the idea of what happens if you actually complete this with an electrical contact, resistance drops again. Of course, I have to hold it just right. Drops almost nothing. That means there's a completed circuit, and if you actually switch the continuity, you could actually hear it. So, that alone, that test indicates that there is no broken circuit. That means that between these two plates and between the plugs and the prong, the connection is solid, and in theory, there is no problem here. So, with that in mind, that means, okay, I've got a problem. If it's working here and in here, then that means the problem is either in the plug or inside. In my case, I really doubt that there's a problem with the plug. After all, the thing just sits there plugged in. I mean, there's a little bit of rust in here, but I don't think that's going to cause an issue. I mean, I could test inside, but I don't really see the point. So at that point, with that in mind, what we're going to do next is take it apart. And I'm really going to take it completely apart. I'm just going to take this off. So it's really not hard to take this thing apart. Go ahead and unplug everything first. Take these things apart, take the flow sensor out. Of course, we've already taken the copper electrode out. And you don't have to take everything off. Just take these two screws. There's a washer on it. Don't lose them if you want to put it back together. If you don't care, doesn't matter. And if it's loose, you can pop it out. Again, maybe you can see a little bit better. There are the three. We'll look at it from the end, it's probably better. Look at it from the end. You can see that there are three plates, and that is plates that allow for detection of salt. So, now that we've done that, there's 4 screws that hold it down. Not really hard to take them out. Of course, there's little washers on the end of them, and each screw. course, one other thing to keep in mind is you want to do this with it unplugged, and preferably you let it sit for a while. So if you're having concerns that the capacitors have slowly lost their charge and thus are not hazardous to your health. Mine's been unplugged for quite some time. So we pull this out. You got to be careful because there's 3 wires. All the little washers fall out. I'm going to turn it around. See what I'm talking about. Now we're looking at the front of the unit. So normally the cell and whatnot, the water would flow back here. Alright, so try to zoom in a bit so you can get a better look at what particularly I'm talking about. Focus in. So this is the inside of the unit. I was rather surprised to notice that you can't really see too well here, but there is a fan down here, a computer fan. Well, I guess which is, you know, fine if you're running a computer like a laptop or, you know, whatnot. Go back. So there's 3 lines, of course, that come to the back. You can't really see them. And of course, there's the switch as well. Inside the case, you have this line, which is the copper cell. It sends current through to the copper cell, and that generates the chlorine from salt in the water. Over here on this side, which you can't see, but it's there, is the flow control, or the flow sensor lines, and then in the middle is the line from the titanium plates, that sensor. And if we follow that one along, in my particular case, it's these lines, and notice here, there's 2. They are rusted. Then this goes off to power and transformer and whatnot. These are part of the electrolytic cell. This is the cable that runs from the LED in the control panel and goes into here, which you got some capacitors down in there and whatnot. At this point, since these 2 are rusted, I thought about trying to pull them off and maybe replace them, because maybe that would be my problem. But they're so corroded, and I don't know this. This may be a rather incorrect statement, but I think the problem is, and why they're corroded and rusted, because this is dry, there's no water in it, is probably because of galvanic corrosion. Of course, this is a saltwater generator, and you can go look on Wikipedia what galvanic corrosion is. So there is going to be some electrolytic presence in the air, I would imagine, and there's going to be 2 dissimilar metals, and since there's a current always running through it, that might be why it's corroded. I think that's the issue. I don't know that. It could be something else. I did try to unscrew them, but I didn't have any luck, and I imagine if I actually put enough pressure on there to get it off, they might actually break the board. And it's pretty much a waste of time anyway to try to go to that much effort to do it, when honestly you can buy another unit for not much money and go another 2 years, or if it fails sooner, as many people report, get it under warranty or get a replacement warranty. So that's it. I'm going to put this back together, and I'll actually probably keep this for parts. The other thing I think I might do in a different video is try to test in the electrolytic cell, see if I can get a reading on the difference in current between regular water, salt water, and then air from the resistance standpoint, and see, you know, just out of curiosity what it should read. It might be useful to somebody else. I know that information would be kind of handy to me, because I could pretty much get an idea without having to go to all this trouble to find out whether or not there's a problem here, and thus know that this is the problem versus something in here. In any case, that's it, and thanks.